Hello, everyone. We should be starting right about now. Let's see if we have everybody here. Yeah. Thank you for joining us. My name is Trilce Encarnacion. I'm professor at the University of Missouri St. Louis, and I'm very happy to be moderating this session. It's a Friday afternoon. You probably have been in other sessions. This is a very interesting one. We have 6 presentations, and I really hope you guys can interact with the authors, even though it's a Friday afternoon. So we are having, like I said, 6 sessions, and the theme of this 6 presentations. And the theme of this session is disasters, resilience, and accessibility. We have interesting presentations from stochastic programming to enhance resilience of infrastructure for weather-related risk, especially heterogeneous impacts of recurring flooding on access, which is really relevant due to the floodings that we've experienced in the Midwest and in Kentucky recently. The third presentation is a risk analysis of bridge damage assessment under the earthquake scenario. So another type of hazard that is very common in California. And we have evolutions in undirected travel satisfaction during the COVID pandemic. The last 3 presentations are focused on pandemic impacts. So second to last is in-person pickup or delivery. We saw a lot of changes in household purchasing behavior during the pandemic, and Maher Saeed is going to talk about that. And our last presentation is going to discuss the impacts of the vaccine rollout on transportation demand. I'm going to start with presenter Ning Zhang. He's going to be discussing a stochastic programming approach to enhance resilience of infrastructure under weather-related risk. He's a researcher from the University of California, Los Angeles. Her research focused on the resilience-oriented optimization of road transportation network under operational and natural hazard conditions. She's also focused on assessment modeling, resource allocation planning, strategy design, and decision-making optimization for transportation systems to enhance network resilience against operational or climate-related disruption via data-driven simulation, benefit to cost analysis, operations research, and parallel high-performance computing. Ning is here, and Ning, do you want to share your screen and start your presentation?
Yeah.
Go ahead.
Hi everyone, my name is Ning and from the UCLA, and today my presentation will be the resilience-oriented optimization of the transportation network under operational and extreme event conditions. So here I will introduce the motivation of my study. The transportation system frequently exposes to aging, deterioration of infrastructures, and weather-related hazards. Disruptions due to the regular infrastructure aging and the damages caused by hazards significantly impact the transportation network functionality. So here I list 2 aging conditions of the United States. The first one is that there are 32% of the American major roads are in poor conditions, and also there are 42% of the national bridges over 50 years. And also the focused hazard of my study is the flood. That is because flood is known to be the most frequent and costly climate-related threat. And it has resulted in 47% of our natural disaster worldwide. And also it has influenced 2.3 billion people worldwide. Flood also induced lots of adverse impact, such as the direct damages of roads and bridges, and also the indirect impacts, such as the traffic capacity reduction, the travel time delay, the change of traffic habit, and the occurrence of traffic accidents. And the last but not the least is the occur of injuries and deaths every year. So here, based on the aging infrastructures and the climate-related hazard that is flood, we want to manage the risk. The reason why we want to manage risk rather than the disasters is because managing risk is inherent to the human development by considering the social and economic activities. So here we will commonly do the three branches of risk management. The first is the risk mitigation, the second is the post-event recovery, and the third is the resilience management that can merge mitigation and recovery together. Of course, the resilience management must be the most effective, but it will also need a lot of efforts to do the optimization. So here I will first introduce the transportation network resilience. That is defined as the capacity of the system to absorb shocks, that is the robustness ability, and to adapt to changes, that is the redundancy ability, and to be able to return to a target network functionality level in time, that is the rapidity. And also the speed of the rapidity is dependent on the resource availability. So that is the last feature of resourcefulness. Since we want to do the resilience management, so we developed the resilience management system, and here we would like to take two parts of actions. And the first one is the ex-ante, or we call the pre-event strategy favor mitigation. And also we will do the ex-post or post-event strategy that will take place after the event. Since we take the two actions, so here we will introduce several features of these two actions. The first one is the two time period. That means a pre and post event. And also we need to do the construction resource allocation, both for repair and both for mitigation and the recovery. And the next is that we need to know our actions impact on users and also the impact on users caused by the flood hazards. And the next is that we need to consider the flood uncertainty in our model. And the last one is that because we need to consider the investment budgets, so we need to prioritize the infrastructures we will mitigate and recover. So based on all these features, we introduce our modeling method, that is two-stage stochastic programming. The two-stage means the two time periods. And the reason why we use stochastic programming is because the stochastic programming points at a time-varying system orientation, and it can help to find a decision involving uncertainty. So here the full name of our model is nonlinear two-stage stochastic programming, shortened as the NTSIP model. The nonlinear is from the transportation operation problem. And the first stage is, or we call the pre-event stage, is represent the infrastructure mitigation against aging. The infrastructure we focused on is the bridge. And this stage will also be called here and now stage, because we need to take action at the current time. And the second stage is that we need to simulate a set of post-event bridge recoveries at different flood scenarios. That is also called wait and see stage. That will happen in the future, but we can check whether what we can do in the future. So here I will also introduce a resilience wave, that is the resilience movement based on our model. So for the first stage, that is the stage before the flood occurrence. So we will do the mitigation to enhance our network resilience or bridge resilience to a higher level. And then when a flood happens, the resilience will drop to a lower level. And after the occurrence of flood, we will start our recovery action and to recover our entire network's resilience to a initial level or a higher level. And this is the formulation of our model. For the first stage, we focuses on the mitigation of our entire resilience management. So we need to know what is the direct mitigation cost and how much we will spend on the traffic delay induced by our construction. And the second stage is a list of flood realization. We need to focus more on the recovery. So we will consider the recovery cost under this flood, and also we need to consider the traffic delay due to our recovery action, and also the traffic delay due to the damage of the network. And the last one is the opportunity losses. That is also be called business loss induced by the flood hazard, that people have to cancel their trips due to the partially closed network. So based on the entire model formulation, we will know that our objective function aims to use the minimization to ensure a resilient transportation system for society from the cost view. So here, I like to introduce two variables. The first variable is the prime decision variable. That is the first stage bridge mitigation variables to decide which bridge will be mitigated and what kind of construction method will be used. That is the primary decision variable due to we need to take action at this time. And the second variable is the second stage variable of bridge recovery to decide which bridge will be recovered and what kind of a construction method will be used on this bridge. So based on our model and our motivations, so how to solve our problem? So I have to say that our problem is complex because we involve three levels of problems. The first level is the lower level, that is the traffic assignment problem. And the second level is the middle level, that is the construction resource allocation problem. This problem is very computing expensive. And the upper level is the stochastic programming model. That is a model to contain a large variance of flood uncertainty. And also we want to apply our entire model to a real-world traffic network. So based on this, we will know that it is impractical to find a solving algorithm with an accurate optimum to fit all problems. So here we introduce the heuristic solving algorithm, that is the evolution strategy, and it can help us to find an approximate optimal solution. And based on this, we will also apply the high performance computing to help us speed up our computing. So here we use 176 CPU cores, and we can control our running of the entire model within 2 days based on our testbed study. So this is our testbed study that is applied in the Transportation District 6 of Iowa state. And based on this network, this network has 5 river basins, the 1, 2, 3, 4, 5. And also we have 300 around bridges. And based on the historical data, we found that the flooded bridges will be 33 bridges. And we also simulated the bridge condition with the bridge performance value in the range of 0 to 1. So on average network resilience, or the network bridge condition, or the network network level bridge performance is equal to 0.68. This is about the scenario generation. We simulated 527 flood scenarios from the flood intensity of 2 rating years to 500 rating years. And This page is about the data specification related to the unit cost value of our objective functions, and also here listed the two construction methods, the accelerate method and the conventional method. The accelerate method is compared with the conventional method that we invest more money to use advanced equipment or work overtime or to use more labors to accelerate our constructions. So this method will be more expensive than the conventional method, but it will induce a shorter construction durations. So the first result is that this table will show the optimal solution of our model based on 3 levels of investment budget. The first from the $15 million dollars budget to the $35 million budget, and this is the optimal solution of whether a bridge will be mitigated or not, and what kind of method it will be used. And based on the results, we could say that with the increase of our investment on the mitigation, we will spend more on the first stage direct cost, but and also we will induce a higher indirect cost on the network. But on the opposite, when we go to the post-flood stage, we will say that because we increase our network to a better level, here is the bridge performance after the mitigation to a better level, so we will have less bridge damaged or lightly damaged. So we won't spend so much money on the second stage recovery, and also we will save a lot of money on the indirect cost. So generally, we could say that with the increase of our investment on the mitigation, we will get a decreasing of our total cost from the first stage to the second stage. So here I will take the one case of $35 million investment to focus on the second stage results. The second stage, I will just show 10 samples because we have hundreds of floods. So like we list one flood in one row, and this is the location where the flood will happen, and the flood intensity, occurrence probability, and also the bridge performance under this flood. And also here is the bridges to be recovered, and also the optimal solution, how to recover these bridges. And based on this, we will know that we also need to evaluate our performance of our model's performance. So here I will give 2 figures. The first figure is the base case that we didn't invest anything in the first stage, and the second stage is our optimal solution under this budget level. So we could say that without the investment, the network resilience won't be increased to a higher level, but under our solution model, we will increase our resilience to a higher level. And also, when the hundreds of floods happens, without the mitigation, the network will drop heavily. But with our model, due to we mitigate the bridges, we will have a lighter drop of our resilience. And also due to we have a better network condition, we will have a shorter recovery at the second stage, no matter for which kind of flood. So based on all this, we will make a conclusion that our model works significantly in reducing hazard uncertainty and promotes the accuracy of the final decision to at most handle the potential events. And also our model gives resilience management insights both in the causal sense and in the functionality sense. Thank you.
Thank you very much, Ning. That was very interesting. Do we have any questions for Ning from the audience? I have a question. I've never seen comparisons between accelerated and conventional approaches. Can you tell us a little bit more about what differences are between these approaches? It's especially also in terms of investment and any trade-offs that you need to consider.
Oh yeah, the major difference is that we didn't do more things about how to design the construction. We consume more on the method to apply the construction. So for the accelerate method, we use the intensive method, like we invest more money to use advanced materials, advanced equipment, or we use more labors to accelerate the construction. But for the construction method, it won't be changed. So this is the difference for the from the construction side. And also for the investment, I have to say that commonly the conventional construction method is cost less compared with the accelerate method. But there is a disadvantage of the conventional method is because this conventional method commonly lasts for a longer duration. So it will induce a lot of network closure, partially or in a large range. Anyway, it will induce the network closure. So we need to do a lot of traffic delay, traffic reroute. We need to reroute a lot of traffic to skip this area. So this is the major disadvantage of the conventional construction. So our research do a balance between the accelerate and the conventional method. We want to spend less money, but we also want to use a shorter construction duration. So this is why we use these two.
Yeah, I understand. It's interesting trade-offs. Alex Bettinardi has a question. Alex, we should be moving to the next one, but let's see your question.
Sure, I might have missed it. I was just curious if anything had been done to assess the increase in likelihood of extreme weather events due to climate change, if that was something that was in any of the work.
Can you explain your question? Yeah, I think I missed your point.
Sure.
The probabilities of the events happening. Did you consider any impact in those probabilities from climate change?
Oh yes, because I have to say that the probability weighs a lot in our model, because in fact we simulate a lot of extreme floods, like 500 rating years of floods. But of course, it definitely will induce very serious damages on the network, but we need to consider the occurrence probability, because the occurrence probability will be low for those very extreme floods. So when we multiply those two values, the occurrence probability and the consequence induced by the extreme floods, the risk value of this type of flood won't be very large, or won't be as large as you thought in the consequence value. So this is how we use the probability in our method. We need to consider the consider the socioeconomic aspect of this flood and its occurrence frequency.
Thanks, Ning.
Yes, thank you.
We're gonna go quickly to the next one.
Yeah.
We're gonna have Luwei Zeng presenting on the spatial heterogeneous impacts of recurrent flooding on axis. She's done a case study of the Hampton Roads region. She's a third-year PhD student at the University of Virginia. Her advisor is Professor T.D. Chen, and her research focuses on transportation systems and social equity. In the interest of time, let's hear from Luwei. Please share your screen.
Okay, yes, let me just quickly share my screen. Okay.
Thank you.
Right, so good afternoon, everyone. My name is Luwei Zeng. Today, I'm going to present my paper here, assessing the spatial heterogeneous impacts of recurrent flooding on access, a case study of the Hampton Roads region. So let me introduce some background first. So accessibility is the ease with which one can attain socio-economic growth through the transportation and land development system. It is a very important measurement in transportation planning. Accessibility considers the value of the destinations, and it can be computed qualitatively or quantitatively. Nowadays, recurrent flooding become a problem. Recurrent flooding is the flooding that happens rapidly in the same area, typically leading to economic losses. This type of flooding increases common maintenance need in coastal regions, and it is exacerbated by accelerated sea level rise, and can be caused by tidal or storm surge. Recurrent flooding catches less attention than other large-scale climate events, because this flooding typically increases travel impedance without enabling access entirely. So why this is important? Recurrent flooding can cause traffic delay. According to Jacob's study in 2018 on the state in the eastern coast US, the total induced vehicle hours of delay due to recurrent flooding exceeds 100 million hours annually. And this number was projected to increase to 1.2 billion in 2060. But in 2021, quantified the annual national level costs due to recurrent flooding was 1.3 to 1.5 billion, and estimate this cost will increase to 28 to 37 billion in 2050. Recurrent flooding might have disparate impacts on populations with different socioeconomic characteristics, and the impact of this diffuse low-cost flooding event will accumulate over time into extremely high-cost outcomes in terms of property value loss. Therefore, it is important for us to understand recurrent flooding and develop measures to mitigate such impacts. And there are literatures in this field. Some of the studies focus on exploring the accessibility change under extreme or large-scale climate events, such as hurricane or disaster flooding. They found that under such events, the service areas of critical facility and emergency service reduced, and the response time increased. For daily activities such as work, grocery, education, these large-scale climate events cause delay or congestion and also lead to trip cancellation. Some studies quantify the flooding impacts on transportation system using various methods. They used hydrology simulation methods to understand the impact of climate change on the transport system. This result focused on exploring the change in accessibility to various destinations under large-scale climate events, because such disasters bring long-lasting consequences and will widely noticed. There are also some studies focused on the recurrent flooding events and investigated the reduction on network-wide vehicle hours or the general accessibility reduction under such events. For social vulnerability frameworks, the Center of Disaster Control and Prevention provide a social vulnerability index guideline. There are studies measure the accessibility of transit for various locations, such as low-income jobs, hospital for socially vulnerable populations. But these studies are not specified in the context of small climate events. So there are 4 gaps can be summarized from the existing studies. First, majority of these studies rely largely on the simulation or forecastic data. This data might not be sufficient to reflect the real situation in transportation system. So in this study, we are going to use observed or cloud source data. Second, the existing studies are more focused on extreme events such as disaster flooding or hurricane, where in this study, we are focusing on small-scale recurrent climate events. To quantify the impact on transportation systems, the existing studies are measuring mobility. In this study, we are measuring the accumulated impact on access, spatially and temporally. Lastly, some existing studies explored who is being impacted for large-scale climate events generally, where in this study, we are taking the consideration for who is being highly impacted by recurrent flooding during specific time period. So the data used in this study can be categorized into 3 types: GIS data, cloud source data, and social equity data. In this GIS data, we have the Hampton Roads layers in TAG's level, and it also contains the population and employment information for each of the TAGs. The Virginia Geography Information Network provides a road network data that can be used to construct road network dataset in ArcGIS Pro. Floating reports and congestion data are obeyed from Wait, which is a smartphone application with real-time user report data. In this study, we used data for August 2018. The location of non-work-related destinations such as bank, education, hospital come from OpenStreetMap, which is a free editable world built by volunteers and released via open content license map. And for the social equity data, we use the social economic data from the US Census 2013 to 2017 American Community Surveys 5 years estimate. The map on the left shows study area, the Hampton Roads region, which is at the southeast of Virginia State. And the map on the right shows the location of non-work-related points of interest in the Hampton Roads area based on the data from the OpenStreetMap. There are 1,173 TAZs in the Hampton Roads, and 1,113 of them has valid road network data and population. The time period classification was based on the peak and off-peak period distinction made by the Hampton Roads region travel demand model. Therefore, waste flooding report and congestion data are split into 5 time periods as shown in this table here, where period 2 is the morning peak hour and period 4 is the afternoon peak hour. The population and work opportunity data for each TAZs from the Hampton Roads Transportation Planning Organization will be used to generate the work-related trips. For the non-work-related trips, destinations such as bank, education, as shown in this table here, are collected from OpenStreetMap and will be used for analyze non-work-related trip accessibility. A verified process is done for selecting flooding reports and congestion lines from waste data. We assume that each flood report have a 50 meters buffer affecting area around it. If there is a congestion line in record within this area, then we consider the flood report is true. And this entire unique congestion line data will be transferred into live barriers in the analyze. Live barriers in ArcGIS Pro's analyze means vehicle can travel along it, but with scaled costs. In August 2018, 12 hours, 31 days had verified flooding reports, with 8 days that had more than 5 verified reports. These 8 days were chosen for analyze, and thus from 20-date unit 20-date time period combinations in the analyze. Other 4 days with less than a handful of flooding reports across the entire region likely experience neglectable accessibility impact. So this table shows the percentage of vehicles report for all 8 days in 5 period. In this map, the red points are the location of original reports, and the green points, are the location of the verified report. So in this study, we used the opportunity-denominated access in combination with the gravity model. As shown in this equation here, we also adjust the population with accessibility as well. We are generating original destination matrix in ArcGIS Pro, where this OD refers to centroid of each TAZ, and network analyze to provide the travel time for one centroid to another through the network. In this study, the travel impedance function is the gravity model, as shown in this equation, which referred to the friction factor in the first equation. Tij is the travel impedance between zone I and j. In this case, it is the travel time between I and j. ABC are the gamma function scaling factor. The parameter for the gravity model come from NCHRP, which is the National Cooperative Highway Research Program. Report document travel demand forecasting. Because the Hampton Roads is classified as a large metropolitan planning organization, which reflecting a population of over 1 million. So the value of parameters are picked as shown in this table 5 here based on the document. In ArcGIS Pro, this projected congestion line is input as live barrier in the network data set analyzed with scaled costs. And the scaling factor is the factor by which the cost of the edge underlying the barriers are multiplied. In this case, the factor is local speed divided by jump speed. And the percentage change in accessibility from the base case to the third disruption scenario, we will calculate for each of the origin TAZs by the following equation here. So this 5 maps shows the percentage accessibility change for walk trips in 5 time period. The darker green means that this area is suffering higher accessibility reduction. As you can see in period 2, which is the morning peak hour, the number of TAZs that are experiencing more than 5% of accessibility reduction is the largest among all the periods. And in period 4, which is the afternoon peak hour, most of the TAZs are having a median impact of accessibility reduction. As for non-work trips, period 4, which is the afternoon peak hour, has the largest number of TAZs that are having a more than 5% of accessibility reduction. So this table summarizes percentage accessibility reduction for both work and non-work trips, as the maps show in the previous 2 pages. Period 2 for work trips and period 4 for non-work trips are highlighted, where accessibility of most TAZs are being highly impacted in these 2 periods. And the population weighted mean accessibility reduction for work trips and non-work trips are highest in period 4, as shown in here. We also investigated which TAZs are most frequently being highly impacted more than once in this case study. So this map shows that most frequently highly impacted TAZs are all within the city of Norfolk area, where you can see some water body near these zones. And the 2 heat maps shows the clustering of highly impacted TAZs with frequency. Darker color means the TAZs is more frequently being highly impacted by recurrent flooding out of the 20 unique daytime combinations. As shown in this map, for both trips, Chesterfield, Norfolk, and Newport News are more frequently experiencing high accessibility reduction, and Williamsburg and Jamestown City are experiencing high accessibility reduction for work trips more frequently than non-work trips. So we have identified the highly impacted TAZ across different time periods, so we need to identify who is impacted during recurrent flooding. We're going to explore the socio-economic characteristics of people living in those highly impacted areas. The social vulnerability index framework was developed based on CDC guidelines. All the data for the first order parameter can be collected from the US census data. Then this first order SBI are summed into 5 categories to get the second order SBI. And to calculate the second order and third order SBI, a min-max scale normalization method is applied as shown in this equation. So this is an example how we calculate normalization, and all the normalized value for the first order variables will be added up to get the second order index, and similar for third order index, and the total value that closer to 1 means more vulnerable. So we applied principle of component analyze to the second order SBI for all TAZs that are being highly impacted by recurrent flooding for both trips. And then the bar plot shows that the people more vulnerable in education and employment and socio-economic status are more likely to experience higher accessibility reduction to work trips. And people vulnerable in these 2 categories might be more prone to accessibility reduction, and it appears that the recurrent flooding might potentially exacerbate this impact. For non-work trips, people vulnerable in social economics and transportation are more likely to experience high accessibility reduction. So in conclusion, in this study, we used cloud source flooding reports and congestion data from WAVE, and we developed a framework that used RGS network analysis and OD matrix generation combined with accessibility calculation for auto using gravity model to capture the spatial and temporal impact of recurrent flooding in terms of accessibility change. This study can also identify the TAZs with largest accessibility reduction and the TAZs that are highly impacted most frequently in study periods. Based on the result, the greatest accessibility reduction occurs in morning peak hour for work trips and afternoon peak hour for non-work trips. With the social vulnerability index analyzed, the study found that population vulnerable in socioeconomic status, education, and employment are more likely to experience high accessibility reduction for work trips across the region. And population vulnerable in socioeconomic status and transportation might be more prone to high accessibility reduction for non-work trips. And this is the end of my presentation. Thank you.
Thank you very much. Does anybody have questions for Luwei? That was really interesting. We recently experienced flooding here in the St. Louis region, and a lot of the impacted population were not able to go to work, not only because of the damage to infrastructure, but also because of the damage to their cars. So do you think that that's being captured with the data that you're getting from Waze? Because there will be less traffic, and it's not necessarily that it's infrastructure related, but that their car was flooded.
Yeah, I think there's something related to trip cancellation, because if their car is flooded, then they cannot travel with the auto, right? They cannot travel with private vehicle. So we also have a study that with the accessibility affected via transit. So this group of people, they might choose to go to work at that day with transit. So we also investigate how this request flooding impact on the transit accessibility as well.
Yeah, it's super interesting. I really like that. Congrats.
Thank you.
Okay, so let's go on to our next presenter. I have to share my screen. We are now going to be hearing from Luwei, and it's going to be presenting a risk analysis of bridge damage assessment under the earthquake scenario case study in California. She is currently a PhD student in Stevens Institute of Technology, researching risk analysis and mitigation, construction engineering, project management, building information modeling, and machine learning application in transportation infrastructure. So, oops.
Okay, I will share my screen. Thank you.
Thanks. If
Thank
any
you,
of
everyone.
you, if any of you would like to play the recording, you can also do that. If you have a recording, you don't have to present live.
Sure, thank you.
Go ahead. Mm-hmm.
Hi, hello everyone. I will present my research paper about the risk analysis of the bridge damages assessment under the earthquake scenario and case study in California. So, as we all know, in the US, bridges has been one of the most crucial components of our infrastructure. Therefore, as some engineers, it's very important to understand the risks associated with bridges so that they may be better prepared for during design, construction, and maintenance. If a bridge were to suddenly fail, lives could be lost, and there would be crippling damage to the local environment and economy. Bridge failures can be due to a wide variety of factors. Broad failure modes such as design or construction errors are quite common. However, more localized modes such as fatigue, corrosion, and cracking may also lead to failure. However, one of the most devastating factors that can cause a bridge to suddenly fail are earthquakes. During earthquake events, all surrounding infrastructure is put at risk, including bridges. By analyzing the risks that are associated with an earthquake-induced bridge failure, engineers, construction crews, public officials, and the public can become more informed about the causes and the effects of these events. The purpose of this report is to develop an analysis method that can be used to quantify the risks associated with bridge damage due to earthquakes in California. So, as we can see from the introduction part, there's a gap between how to quantify the risks with the bridges under the earthquake event in California and between the current literature, how we can use the more proposed new method to quantify the risks with the bridge damage in California. So in our methodology, we will try to use the event trees and sensitive analysis, fundamental objective hierarchies, the mean objective networks as our prioritized and selected approach for quantifying the risks associated with bridge damage following the earthquakes. So a thorough forensic analysis was conducted. The results of this analysis would allow for multiple stakeholders to make decisions as to how to best assess the risks that are associated with bridges in California being damaged due to the occurrence of an earthquake. So as we can see from the first portion of event tree in the methodology, an event tree is a commonly used tool in risk analysis and studies. It is an analytical diagram that are used to examine an initiating event followed by a chronological series of uncertain events and quantify their associated probabilities of occurrence and the consequence. For this study, the initiating event would be the occurrence of a single earthquake somewhere in the state of California. Assuming an earthquake occurs, a series of uncertain events must be evaluated. In this figure, it presents the event tree that was developed for this risk analysis. The probabilities of each failure mode that can be seen in the event tree in figure. Yet, it is still important to include the earthquake severity in this risk analysis, as a stronger earthquake leads to more devastating results. Thus, earthquake severity was divided into 3 groups: low magnitude less than 4.0, medium between 4.0 and 7.0, and high larger than 7.0. A low magnitude earthquake will most likely not cause damage to major structures such as bridges. A further uncertainty that will impact the severity of the consequences is bridge type. Moreover, the type of bridge crossing will greatly impact the type of damage that the bridge will be most vulnerable to. If a bridge passes over a waterway, it will be more vulnerable to liquefaction and scour failure, which are 2 of the major failure modes of a bridge during earthquake events. On the other hand, if a bridge passes over a railway, damage to the piers and the bearing connection will often be the governing failure modes. The final uncertainty that will impact the severity of the consequences that type of damage the bridge is most likely to experience. For the scope of this study, 4 damage states I could consider: foundation damage due to liquefaction and scour, pier damage due to pier or connection failure, total damage, bridge collapses, or no damage. The first 2 damage states are more common in bridges where most likely only require maintenance and repairs. On the other hand, total damage means that the bridge has completely collapsed and complete reconstruction will be necessary to restore it. It was assumed that any bridge in poor health will reach the total damage state. Lastly, no damage means that the damage to the bridge can be considered negligible, as there is no expected drastic loss of functionality. As previously mentioned, bridges passing over water are more likely to experience foundational damage, and the bridges passing over highways are more likely to experience higher damage. The consequence presented consider only the cost of repairing the bridge. They do not consider other losses such as injuries, loss of life, or damage to surrounding infrastructure. These costs are estimated based on historical data. The cost of total damage is assumed to be 100 million. The cost of repairs due to foundation damage is assumed to be 10 million. And the cost of repairs due to pier damage is assumed to be 5 million. The cost of no or minimal damage is assumed to be 0. These assumptions were based on the repair values after the North Ridge earthquake that occurred in California in 1994. Upon completion of the event tree issued in the figure, the probabilities of occurrence for each scenario were calculated. It can be seen that the most likely scenario to occur is that a bridge is undamaged because it was not within 300 miles of the earthquake's epicenter. Similarly, there's also a high probability that an earthquake would be of low magnitude, meaning that a bridge will not be damaged during the earthquake. When coupled with no or minimal damage states, it can be concluded that by this analysis, there is a 62% chances that there will be no economic consequences as a result of an earthquake. However, there is a 38% chances that an earthquake would result in some form of economic losses. These results are summarized in the cumulative distribution function plot in figure. So, as shown in the figure in the table, there is 38% that chances that would be losses as a result of an earthquake. Of this 38%, there is an 11 chances that would be 100 million in losses, and a 52% chance that would be 10 million in losses, and then also 11.8% that chance that there would be $5 billion in losses. Thus, it can be stated that if bridges were to experience damage during an earthquake, foundational damage is most likely to occur. However, the probabilities of pilot damage and total damage are still significant and must be considered. When all probabilities and consequences are considered, it can be stated that on average, the expected value of the damage to a given bridge, given the occurrence of an earthquake, would be 13 million approximately. So next, another important step in the methodology of our portion of our section is that we want to perform a sensitivity analysis. As see, we can find this figure in the table. For this study, it was decided that the proximity, magnitude, and bridge condition variables would be altered for sensitivity analysis because these variables have the most uncertainty associated with them. It was also decided that the main focus of this analysis would be analyzing how the change in these variables impacted the probability of total damage or collapse. Since this is the most severe consequence, it is most important to understand how this outcome is affected by the different variables. Proximity was varied in a way that made it more likely that a bridge would be close to an earthquake, given the size of California state and the location of the San Andreas fault. In addition, only the medium and high earthquake magnitudes were different and vary from each other, since a low magnitude earthquake will not impact the likelihood of total damage. Furthermore, bridge condition was different or varying from each other in a way that simulated the degradation of bridge condition over time. By altering these variables, it can be determined which event will play the biggest role in determining the risks associated with total bridge damage due to earthquakes in California. When sensitivity analysis of the probability of total damage is conducted, conclusion can be made that which factors impact consequence the most. From this figure, it can be seen that one variable was changed, while the others are held constant. The consequences were different from different level. Furthermore, based on the initial probability of total damage of 0.11, judgment can be made as to how severe certain variables will impact the overall consequence. The overall conclusion from the sensitivity analysis is that bridge condition is the most influential factor contributing to the probability of total damage. By increasing the likelihood of the bridge being in the poor condition from 0.2 to 0.5, the probability of total damage increases from 0.11 to 0.227. Essentially, the worse condition of a given bridge is, the more likely it is to fail completely. From this study, we can see that due to the assumption that the bridge would experience little to no damage from the earthquake, so that is a higher probability, 62%, that there will be no economic consequence or loss for any bridge in California given an earth happening. So, based on the distance between the bridge and earthquake, different magnitudes of earthquake, bridge conditions, and bridge types, different types of damages will be experienced with corresponding consequence. There's a 11% chance that bridge will experience just prior damage resulting in 5 million. As we have mentioned before, accordingly, that on average, the expected value of the damages to a given bridge upon the occurrence of an earthquake will be 13 million. So, from the sensitivity analysis, we can see that the variability in the current bridge condition has the highest influence on the probability of a bridge failing during an earthquake event. This can be seen given the fact that if the bridge is in bad condition, we assume that it will face total failure. With this data, future work can look into retrofitting bridges that are found to be more susceptible or vulnerable to earthquake damage. However, there are somewhat limitations that were faced when conducting the risk analysis of bridges. This particular analysis does not go into the detail or evaluate the multiple components of a bridge. The bridge is diagnosed and assessed as one whole component with condition based off an assessment of recent inspection. So, in order to mitigate the risk of all bridges, it would fall on the shoulders of government officials and engineers to decide how to best scale this strategy up. Decisions would need to be made as to which bridges get retrofitted and inspected firstly. These decisions could be made based on traffic volume, age, as well as potential cost of reconstruction. Thank you, everyone. And I'm happy to take any questions as you requested, assume that you have a question. Thank you.
Thank you, Luwei. Do we have any questions? we have time for questions. We've made up for the schedule, so. So Yue, it seems like in your study, your methodology really accounts for a lot of different risk profiles. Do you think what would be the main takeaways for policymakers from this study?
Yes, I think for the policymakers, because typically we use a lot of deep learning or deep machine learning, such as for the image segmentation or image classification to detect or localize the damaged part or damaged portion from the bridges. So, but that will take a lot of time because we need to use manual annotation and then use some segmentation process. So it takes very time consuming, and also we have to do it in a very exhaustive way. So for this risk analysis, it's less complicated than the traditional machine learning or deep learning methods or approaches. So for this method, I want to use this method because it can help to inform the policymakers and the public officials in a more time efficient and cost efficient way. Because as you can see from the figure, they use probability analysis, statistical analysis, and the event tree, fundamental hierarchy, and the means objective hierarchy. So they are not extremely complicated, but they can help us to learn from how the damage happen or which type of factors such as bridge type or bridge condition affect the earthquake damage after the earthquake happens mostly in a most significant way. So we can learn some distributions in such a very effective manner. So that's my takeaway, why I want to, how I can inform the policymakers in a more proper manner or in reasonable manner. Thank you. You are muted.
Okay, yeah, that was really good. Thank you very much for your presentation.
Thank you.
Let's move to the next one. Share my screen. So exciting. So now we're going to be moving to the next half of our session, and we're going to be seeing presentations related to the COVID pandemic. And we have Hannah Cook. She's a doctoral researcher at the Geography Department of Ghent University, working in the Social and Economic Geography Research Group. She holds a master's degree in sustainable cities and a master's degree in GIS technology. Her research focuses on undirected travel, or travel for its own sake, daily travel behavior, and urban mobility. She's going to be discussing evolutions in undirected travel satisfaction during the COVID-19 pandemic. Hannah, I understand you have a recording. If you want, you can play that, or you can go ahead and share your screen and present live. It's your choice.
Yeah, I'll go ahead and present live. I think it's a little more personal. Okay. And can you see it?
Yes, we're not seeing it. Yeah.
Is it the correct view?
You need to switch.
Yeah. And now?
Let me see. Yeah.
Okay, perfect. Hello, I'm Hannah Hook. I'm coming from Ghent University in Belgium, where I'm a doctor. Oh, it's starting on its own. Where I'm a doctoral candidate, and I work in the Social and Economic Geography group in the Geography department. And I'm going to talk about undirected travel and how it changed throughout the pandemic, and how we used it to improve our well-being a little bit. So, sorry, it's going without my permission. Okay, so undirected travel is, just to offer a quick definition at the beginning, it's travel that's taken for its own sake. So it's not like the commute, or it's not like shopping trips where there's a clear destination. Undirected trips don't have a destination, or the destination is not important to the travel. So these are trips that are taken just for the purpose of being on a travel trip, and it's not determined by needing to get somewhere or really without any time constraints. So these often come in the forms of active modes. So this would be like taking a walk, taking a cycle, going on a jog, bicycle ride, sorry, going on a jog. But it certainly can also be undertaken with motorized modes. So going on a joyride by car or motorcycle, getting on public transit just to ride it, or taking a boat trip, even these Qantas 7-hour flights to nowhere that were offered for the Australians that were missing a little bit of traveling. These would be considered undirected travel flights, or undirected travel because they don't have a so indeed, the destination is, needing to get somewhere is not a, I don't know what's going on, sorry, it's just moving. There's not a requirement to be physically active during an undirected travel trip, but instead that there is no destination, or that the destination is not the main purpose of the travel. And this is particularly interesting to investigate during the COVID pandemic, because as I'm sure you saw in a lot of your own neighborhoods, we were in these kind of really strict lockdowns, but people were still out and about, kind of going on walks, getting out of the house, clearing their head, especially when the weather was nice. So this it created this kind of test scenario for us to investigate these types of trips. And there were 5 kind of overarching themes of travel behavior during the pandemic, not necessarily just related to undirected travel, but related to all types of travel. So there was obviously a reduction in mobility. There were spatial temporal adjustments. There was modal shift. There were new or reduced out-of-home activities, and there was digital adaptation. So we started teleworking more. The primary trip purpose became shopping. We were going for shorter distances on our trips, but not necessarily duration, which means we had a smaller activity space. Yeah, sorry about this. And we took trips less frequently, and our modal choice shifted away from shared mobility toward more non-motorized modes for short distances, and then more private cars for long distances. So we saw a general reduction in daily travel, but undirected travel was increased. So people started taking more of these types of trips, and maybe there was some sort of compensation for a reduction in directed travel with undirected travel. So especially during the pandemic, it's likely that people were doing this to get out of the house, get active, meet friends, or just have something to do when there were a lot of places that were closed or it was prohibited to go. And so because of the relationship with undirected travel and higher satisfaction, this could be a mechanism to improve well-being, especially for people who are maybe having a little bit more of a difficult time with the pandemic. And we saw this at the beginning, so we wanted to see if maybe this continued as the pandemic persisted and those regulations started opening up and people could go back to their kind of normal behavior if they kept doing these undirected travel trips. So this was the result of a longitudinal panel survey where we did the first wave at the very beginning of the pandemic, and then we did another wave 1 year later when we recontacted those initial participants and asked them about their undirected travel behavior. So just for a bit of context, the pandemic or the restrictions were super, super strong in the first one. We pretty much weren't even supposed to leave. We weren't supposed to leave our houses unless it was truly necessary. And then a year later, the restaurants were back open. We still had restrictions with like capacity, theater productions and things like that weren't going on, but for the most part, people were a little bit more free. So we had a response rate of 322 of those people that were recontacted, and they gave us information over their undirected trips in both the first and the second survey. So what we did was we looked at paired sample t-tests for trip attributes, motivation, and satisfaction between the 2 waves. So the attributes were frequency of undirected trips, distance, and duration. Motivations were improving physical health, improving mental well-being, enjoying scenery, and out-of-home socialization. And then we identified 5 behavior profiles based on their modal choice, which I'll talk about more in a minute. And we then we investigated those behavior profiles with multinomial logistic regression based on socioeconomic demographics and household characteristics. So results of the paired sample t-tests show the kind of open empty bars meant that there wasn't a statistical significance, and then the solid bars meant that there was. So duration of undirected trips did not change significantly, but they were longer in distance and less frequent. So people were going maybe for longer, further distances, like taking, maybe they got faster at their bicycle rides or things like that, but they were taking fewer of them when they were able to go do other types of activities with the loosening of the restrictions. Regarding the motivations for undirected travel, people were more inclined to be motivated to improve their physical health, their mental well-being. There was not a significant relationship with enjoying scenery, and they were less inclined to be motivated by socializing, which makes sense because maybe if you were taking a walk to meet a friend before, and then now you could meet them at a restaurant, maybe you didn't need undirected travel for socialization. And then for the satisfaction with travel scale, I forgot to explain on the last slide. So we used the emotion and evaluation components. So emotion is like how they felt during the trip. I felt bored, I felt anxious, I felt happy, I felt excited. And then the evaluation is questions like, that was the best trip I ever took, that was the worst trip I ever took. I would rank that, I felt good about that trip. So for both satisfaction with travel components, satisfaction increased over the course of the pandemic. So maybe people were getting, incorporating them more into their, routines, and then maybe getting more satisfaction over time out of their undirected travel trips. And then in order to identify the undirected travel behavior profiles, we looked at the modal shift. So this is a Sankey diagram just showing how people changed from the starts to 1 year into the pandemic. So you can see 162 people stayed with walking. Some people shifted their modes to cycling or other, which included all other types of undirected trips, not just other active undirected trips. And then you can see, and then of course, some people didn't participate in undirected travel at all, either at the beginning or at the end of the pandemic. So we were able to identify 5 behavior profiles based on the modal shift. So those who kept the same mode, those who began undirected trips, those who stopped undirected trips, those who changed their mode, and those who did not participate in undirected travel. And you can see the kind of breakdown of those here, with the largest group staying the same, about almost 20%, 19% stopping, and then 8% starting and 12% changing. And then regarding the multinomial logistic regression, I know this looks really like big and super complicated, but I won't talk about all of it. I'll just point out that the full sample is in white. And then these are just the how each of the different groups averaged against the full sample. So yeah, not into the multinomial logistic regression yet, sorry about that. So associating, starting with women, females were associated with starting undirected travel or not participating in undirected travel at all. Younger people were not associated with starting undirected travel. So they were, maybe more likely to keep the mode, stop or change, but not as likely to start undirected travel. And the same goes for the 26 to 40 group. The kind of middle-aged 41 to 55-year-olds, on the other hand, were more likely to start taking undirected trips over the course of the year. And then the oldest group, the over 55, were not likely to participate in undirected travel at all. Those who were employed and studying were likely to take undirected trips, so they were less likely to be in that no undirected travel category. Those with higher income were with lower income were associated with not participating in undirected travel, starting or stopping undirected travel. And then those who were university educated were associated with not starting undirected travel, and then not changing and participating in undirected travel. I know that's kind of confusing, but I think it will get more clear with the multinomial logistic regression. And then regarding the household characteristics, it's not working. Those with car access were likely to start undirected travel. So that, I guess, maybe they were hopefully leaving their cars at home a little bit. Those with bicycle access were not likely to participate in no undirected travel, which makes sense because if you have a bicycle, you might be more inclined to use it. Those with the balcony or terrace were likely to start undirected travel. Those with a garden were likely to stop undirected travel. Those who live alone were not likely to participate in undirected travel, and those with a small living space were also not likely to participate in undirected travel. And then moving on to the multinomial logistic models. So the reference category was the same, that largest category. And they were, so the other 4 categories were compared to those who kept the same mode. And then again, the open bars are the non-significant relationships and the closed bars are significant relationships. So those who reported using the same mode, or sorry, those who started undirected travel were less likely to be university educated and less likely to have bicycle access. Those who stopped undirected travel were more likely to have a household income lower than 3,500 euros per month and less likely to have bicycle access and more likely to have a garden. Those who used a different mode were likely to be older and university educated, and those who did not participate in undirected travel were more likely to be female, older, and less likely to have bicycle access. So in sum, what does this all mean? Undirected travel satisfaction increased over the first year of the COVID pandemic and remained specifically important to improving physical and mental health and well-being, which indicates that undirected travel remains important even when the pandemic restrictions loosen, and therefore it might be an important way of enhancing well-being after the pandemic, just generally as we move on. And then we identified 5 profiles of undirected travel behavior. Participating in undirected travel was linked to being male, being middle-aged, being employed, and in higher income and education categories. And then unsurprisingly, bicycle access was found to be important to undirected travel. So that could indicate that a rediscovery of cycling might be a result of the pandemic for some people. So future research could aim to recognize distinctions between directed and undirected travel trips, because undirected travel is unique in that it's strongly and positively linked to travel utility, satisfaction, and well-being. And we don't really know about the share of undirected travel trips compared to total travel. So that is something that we should look into further because it might be more important than we think. But on the other hand, given those who are associated with taking undirected trips, the research signifies that there might be equity issues associated with undirected travel. So we should consider how and for whom mobility systems are planned and how we implement them. So as travel behavior norms return to normal, we can maybe try to think about this from an equity standpoint and realize that we're dealing with complex and interconnected problems, even when we're talking about just taking a walk. And finally, undirected trips are important. We know that people like to take them for the 4 reasons: physical health, well-being, exposure to nature, and social cohesion. And we know that people often take them with active modes. So we use active travel a lot as a response to global crises like climate change or the obesity epidemic. So this could be a tool if we could integrate more undirected trips into our behavior. And especially given as they might compensate for a decrease in directed travel trips, we can maybe use this going forward as trips become more discretionary, as we start to telework more, we teleshop, we do telehealth appointments, all of these different things. We might not be taking as many directed trips. So we can look to undirected travel trips to maybe compensate, and they might become more important to total travel. So in the future, we could prioritize street experiments that redirect traffic to have street calming and relaxing. We could improve green space to make our experiences on the route more enjoyable. We could have anthropocentric infrastructure that gets more people out in social cohesion, improving walking and cycling paths and building activity parks, getting people out and being more physically active. So quickly, I'll thank my co-authors, Jonas De Vos, Veronique van Acker, and Frank Witlox. And I'm Hannah Hook. Thank you for your attention, and hopefully there'll be some questions.
Great presentation, Hannah. We have a couple questions in the chat already. Alex has a question related to something I was going to ask. He says, I'm interested if in your work you have thought about the definition of what makes a trip. Example, if an undirected traveler is getting health benefits from riding on a treadmill, should that count towards undirected travel miles? I don't think I mean, you mentioned it a little bit in the beginning, but I didn't get like a proper definition of undirected travel. Can you elaborate on that?
Yeah, so being on a treadmill wouldn't count as undirected travel. That would just be a physical activity, right? So undirected travel is like travel that's taken for its own sake. It's like meant to be out and moving around. And it doesn't depend on physical activity. That's not a sufficient condition nor a requirement of undirected trips. So they're more like, yeah, they are definitely mostly physically active, but even just taking a joyride, you know, if you think about like the 1950s and the kind of drag strip with cars going up and down with teenagers and they have nowhere to go, that's undirected travel as well. So just like trips that are taken for the act of traveling.
We have another question here from Andressa. Hannah, thanks for your presentation. What do you think about the evolution of these trips in the future? In Brazil, for example, we use a lot of private transport cars, and incentives are given to the automotive industry. Fixing these historical errors will take time, and public transport faces challenges here. What steps could be taken towards more sustainable travel? I think there's two questions here. Evolution for the trips in the future. I think you talked a little bit about that at the end, and somehow how can this relate to making more sustainable travel?
Yeah, I think they do relate. I see you know, the kind of movements for the 15-minute city and these really local, these pushes for having everything that you need in your area, that not only will get you to maybe be more physically active while you go to your directed trips, but then it also teaches you about your environment. So maybe you find a park that you didn't know about, and then you take more undirected trips to that park or things like that. And then I think also the link with more online activity, it makes an opportunity for these trips. So for example, teleworkers could maybe be incentivized to go on a walk during their lunch breaks, or they could, or maybe they just will do it anyway because they need some sort of travel to break up their activity. I know that's like how a lot of people are feeling when you don't get that time to clear your head between work and home on the train or in the car or on the bicycle or whatever. You might still just leave the house just and travel just to have that because it's associated with like getting a break between work and home. So I still think that they could be like integrated into like, yeah, teleworking policy, or maybe it's a transition we can make as we take more discretionary trips.
Any other questions? Well, this was very interesting, Hannah. Congratulations, great work. Thank you for sharing.
Thanks.
Now we are going to hear from Justin Drummond. Let me make sure that this is it. No, I'm sorry. We are going to hear from Maher Said. I knew I was like, I got ahead of myself there. So Maher is going to be discussing in-person pickup or delivery, evolving patterns of household spending behavior through the early reopening phase of the COVID-19 pandemic. Maher is a PhD candidate at Northwestern University and a Buffett Institute Global Impacts Graduate Fellow. His research interests are in behavioral analysis and choice modeling, active mobility in developing countries, and near future adoption of novel automated technology. He's also a data scientist working at WISC and providing insight on the future of urban air mobility and potential adoption patterns. We have Maher here.
Yes.
There you go. You can share your screen and go ahead. Looking forward to it.
Yes, thank you. Yeah, so my name is Maher, and I'm going to be talking about work that we did as part of the Telemobility UTC, which focuses on how spending patterns have changed during the COVID-19 pandemic. And this is important for us because eventually spending is a precursor, or at least related to mobility in one way or another. Yeah, so as we all know, I don't need to go over this. COVID-19 has had a huge impact on livelihood and almost every system of society, whether from shopping, whether traffic, trucks, etc. And this has just had major shifts in how people move, spend, and consume. And very early during the pandemic, we start seeing a lot of news about how spending is changing, how the economy is contracting. There were fears about recessions and all these things. So quickly we became interested in tracking that information ourselves and studying it. So the goals of this research is to examine household spending and purchasing behavior during the evolving stages of the COVID-19 pandemic. We were mostly focused on the period between December 2021 to March 2022, which was the phase when things were kind of reopening at that time. And people were going back to their lives, 2020 to 2021. So December 2020 to March 2021. So yeah, we want to provide insights regarding changes in spending across that time and what factors were affecting spending, and kind of analyze purchasing behavior. And we want to do it across different channels because, you know, people were doing a lot of deliveries, people were getting into pickup, and we wanted to understand how sustainable any of those systems were, whether they're here to stay, whether, you know, they were already gone at that time. And we'll get into that as we show the results. So this is, as I said, part of the UTC Telemobility, and it's a huge study that's actually still ongoing. So I know the last date I show here is March 8th, but we're still collecting data. And for this study in specific, we're just focused on two tiny bits of the data we collect as part of the UTC, which is that specific to expenditure. And we have two categories of spending because the way we were approaching data collection is we had questions that were bi-weekly. And here by bi-weekly, I mean once every 2 weeks, where we were asking them to look back at their last week and tell us how their behavior was during the last week, in this case for expenditure. And then there were the monthly categories, which were miscellaneous categories where we asked them to look back at their month and let us know how much spending they've done during that month. So regarding the categories that we're going to be discussing today, we have 6 categories in total, but we're going to start first with the 3 weekly spending categories. So we had groceries, and groceries is anything that you can buy or you would buy at a grocery store, from food to soap to detergents, etc. Prepared food, and we did not differentiate between restaurant meals or restaurant delivered food or other kinds of prepared food. So there's a lot of prepared food delivery services like Factor, for example, and then anything other than those 2 categories. And then I got among our monthly spending categories, and they kind of fall under other, but those were ones that we really wanted to specifically target: digital consumption, clothing and apparel, and home improvement. So these are 3 major categories that we noticed from reading the news or even seeing early research that really were impacted by the pandemic and that are big enough categories for us to analyze. And here are sample questions that we asked in the survey. There's many more for different categories, but just to give you a sense of how these questions were asked, we tried to keep the wording as neutral as possible. We also tried to be as clear as possible so that we really hone down into what we're trying to collect. So as an example, how much has your household spent in groceries in total over the last week? Or when we're asking about pre-pandemic, it would be kind of a recall question. Before the COVID-19 pandemic, in a typical month, how much did your household spend? And just to make sure that the respondents really differentiated between pre-pandemic and pandemic questions, we had them in different colors. So the green color you see here is kind of consistent. And I'm not going to go through this slide, but just to give you an idea of the sample size and people who responded and the frequency at which we were asking different questions. Here's a quick summary. Overall, we had on average roughly 500 respondents per survey wave. Some of them returned, some didn't, so we had to add new respondents. But overall, we have 972 responses that went into this study. So looking at average values here, so we're kind of doing exploratory analysis here, and there will be some more modeling down the line. We can start seeing some trends that were happening during this period of the pandemic compared to pre-pandemic. So the dates are in the bottom, again, December 21, 2020 to March 8, 2021. And one thing we quickly noticed is a sense of stability in average spending during the period during which we collected data. The one thing that stands out is other spending during Christmas week or right before Christmas week, which is understandable. That's an outlier. What we noticed is slight decreases here and there in in-person spending, as we'd expect. Slight increases in pickup and delivery spending, as we'd expect. But for prepared food, interestingly, unlike groceries, we see a decrease in in-person spending, but we don't see a counteracting increase in pickup and delivery. If anything, the total spending decreased, which kind of already hinted to us that people contracted how they're spending on non-essentials, which was prepared food in this case. And a lot of people also were experimenting with cooking at home and all these things. We also, during the exploratory analysis phase, we looked at different socio-demographics. I'm only showing 2 out of the 10 to 12 that we looked into to see if we can spot any early trends. 2 interesting trends that we can see here is, again, looking into prepared food. We noticed that as age increased, older people were less likely to spend on food in person. And in person means that you're going to a restaurant. So more concerned about the pandemic, less mobility, very understandable. We also see politically that liberal people, or people who orient themselves liberally, were much less likely to go to restaurants and eat there compared to conservatives. But also, there was decrease among conservatives as well. It's just that liberals decreased their spending. So regarding modeling, we needed to kind of show the information that we just showed, but controlling for a lot of the aspects that are not controlled for in simple averages. So we chose the hurdle model to resolve the issue of a lot of zero responses, because not everyone is spending week to week on a number of these categories. So in hurdle models, what we're going to see is we're going to see the first arm of the model being the binary arm, which shows whether someone does spend, or whether someone spent or did not spend during that week any amount. And then a continuous arm that shows for those who have spent an amount of money, how much have they spent? And this is just the formulation for a hurdle model. It's basically a logit model for one arm and a linear regression for the other. And here we can look into whether people are spending at all or not for different categories and different channels. So one thing that we notice is that grocery spending, people are less likely to spend on groceries or to do grocery trips in person especially, but more people start adopting doing pickup and delivery for groceries. For prepared food, like we insinuated to earlier, there is an overall decrease, especially in in-person spending. For other spending, we see kind of a stable spending pattern, and even for miscellaneous spending, we see a generally stable spending pattern. Now, for those who did spend, this is where we start seeing some more, some instability. We're not comparing to pre-pandemic here. Actually, I mean, sorry, we are comparing to pre-pandemic. So all these values are percent spending change compared to pre-pandemic. And we noticed that for those who spent on pickup and delivery, although the increase of percent of people who spent on pickup and delivery was small, they started spending much more. So a lot of people were spending, some people were spending a lot of money on pickup and delivery. For prepared food, most of the error bars kind of intersect with zero, so there isn't much going on. Although early on in the pandemic, early on data collection, there was some increase in spending. For other spending, again, a lot of insignificant change in spending. The one interesting one that I want to highlight here is home improvement and electronics. So although when we go back to the previous chart, we see that not a lot more people are spending on home improvement than they were pre-pandemic. And this kind of stood out because whenever we heard of in the news, they were talking about very increased spending during the pandemic on home improvement. And this is where we see it. So same amount of people still doing home improvement purchases. It's just that some of them are spending a lot more money. And we also wanted to go an extra step and start looking at sociodemographics and controlling for them in terms of spending. So I'm highlighting, again, just 5 out of roughly 10 sociodemographics that we looked at. And I'm only focusing on the binary arm where we saw most of the interesting relationships. There weren't a lot of sociodemographics that were significant for the continuous arm, which is the amount spent. And one thing to notice here is that households with higher income who used to spend much more in person, who were much more likely to do shopping in person pre-pandemic than lower income, suddenly the relationship became insignificant during the pandemic. So for in-person shopping, it didn't make a difference whether you were higher income or not to make a trip to buy something in person. In terms of number of vehicles, I want to highlight for delivery, where we're seeing a lot of people adopting delivery shopping. A lot of people who had a lot of vehicles or a greater number of vehicles kind of didn't need to depend so much on delivery themselves. So instead, they were depending more on pickup, which we see here as a significant variable during the pandemic. Going back to our previous comment about age, age was not significant pre-pandemic in terms of whether or not you go and do your purchases in person. However, during the pandemic, it became where people who are older are less likely to do in-person purchases. But for delivery, it was the other way around, where younger folks bought more things through delivery pre-pandemic, but during the pandemic, the relationship was insignificant. A bit expected is that essential workers, so people who had to kind of work in person, were doing more shopping trips in person than people who are not essential workers during the pandemic. And here we're not comparing to pre-pandemic because the concept of essential worker did not exist pre-pandemic. So this is just in isolation during the pandemic. But also they were much more likely to use pickup services, whether because they already have to go out of the house or whether because of the nature of their work, they were a bit more tolerant to interacting with people. Politically, the more conservative people were, they were much more likely to resume their in-person shopping, but also they were more likely to adopt pickup deliveries, but for pickup shopping, but for deliveries, there was no significant relationship there. So to make some final remarks, spending had stabilized to pre-pandemic levels at the time of the study, except for a roughly 30% average decline in restaurant spending. There was a sustained shift in spending channels towards online purchases, with roughly 40 to 60% more expenditure through these channels compared to pre-pandemic. So although overall spending is stabilized, there was some shift among channels. And yeah, there seems to be some inertia and behavior that happened during the pandemic and that was sustained during that period. So for future work, which is regarding data that we're still collecting, it would be nice to analyze this spending during a longer timeline. And we're still collecting data till today that we plan on analyzing and kind of adding to this work so that we see if that stability is sustained across a year or even 2 at this point. And so that we get better understanding of what's going on and what might happen in the future. So yeah, I want to thank my co-authors and the people who made this happen. We do have another study that I'm mentioning here as part of the series of studies that is going to be coming out. If you want to look at the preprint, please email me. My information is there. And if you have any questions, please feel free to ask them.
Thank you so much, Maher.
Thank you.
Very interesting study. We have a question from the chat. Let me see. Yep. Andressa is asking, excellent research, Maher. Here in Brazil, there was an increase in purchases in the sub-centers, neighborhoods. Families who used to travel before the pandemic to shop in large centers began to buy in places closer to their home. This has reduced congestion in large cities. Is this something that you guys tested for or evaluated?
Yeah, so first, Andressa, I was born and raised in Brazil, so I know a bit about that. The thing, we did collect that kind of data. So we have data about how many trips people were making, how much time those trips were taking, and the distance of those trips. And that's something that hopefully should follow this study and expand on it. This was the first study because spending was kind of our starting point, but we want to add to it where we do look at whether people traveled more, whether the distance of their travels increased or decreased. I know I have a colleague that was looking at the activity frequency, and I think he was looking at distances as well. A lot of TRB studies going on, so I kind of, they're a bit hazy in my head. But yeah, it's definitely something interesting, something that we will look at.
I have a couple of questions. This data that you're collecting is a multi-wave study, right?
Yes.
Are you having the same participants or is this random sampling? I don't think you discussed a lot about the sampling method.
Yeah, no, we are having returning respondents. I just didn't want to spend too much time on this slide. But yeah, we are re-inviting all good respondents, which honestly is roughly 99% of the people we survey. And they're still being re-invited till today. Obviously, the longer the survey keeps going on, the more drop-off we have. So we do re-add a few respondents as needed. But let me see if I have the number. Yeah, so returning respondents by March 8th from December 21 was 516 respondents.
Okay.
So those people did at least filled one wave prior to the last wave that they participated in.
I see. And how are you collecting this data? Through...
Yes, so it's a representative sample that we're collecting through Qualtrics online.
Oh, Qualtrics.
So, yeah, and we're distributing it on Prolific. So survey design and Qualtrics, Prolific is the distribution.
I've seen a lot of use of Prolific recently. So
yeah, it's as Amazon and Turk became slightly lower quality, Prolific stood out as the place to go to.
Yeah. Anybody else want to ask another question? I have many. So I don't want to hog, monopolize the conversation. The other one is kind of random. I read that article in Wall Street Journal about Home Depot, and it's really surprising that Home Depot had a really good year.
Yeah.
So they sold a lot and their profits increased a lot. They were able to manage all the supply chain. I mean, the supply chain issues were not impacting their profitability, which is amazing. So I mean, without looking at any data, I would have thought it was just more people buying things, but it seems that it was the same people that were buying more.
Yeah, I mean, when we saw the data, we were a bit surprised to see a bunch of the stability that we're seeing. But now in hindsight, so, when we're analyzing it, we're in the deep end of it. But now in hindsight, this was right after Omicron when it happened. At that point, COVID, people were used to COVID, not much was happening. So I think this was a bit of the boredom stage of COVID. Unlike the early months of COVID, where everyone was suddenly a baker and had plants and was doing all these new recreational things at home. So yeah, it seems that the same people were spending more. So maybe it was people who already started their home improvement projects and were really going all the way with it, but it's not an increase in people, at least.
Yeah, that's why it's interesting to do the things like timely, because I think that was 2020 was that year, and you started collecting data in 21. Did you ask respondents about their pre-COVID responses, or did you collect data pre-COVID?
No, I mean,
You
sadly,
asked them, stated,
yeah,
right?
sadly, the pandemic is not something that you can predict.
No.
So with the recall question.
Yeah. Okay. Super interesting. Thank you for sharing.
Thank you.
Since we don't have any other questions, let me make sure that I have the right slide now. We're gonna go to our last presentation of the session. And we're gonna be hearing from Justin Drummond. He is a second-year PhD student at Howard University and a recipient of the National Science Foundation Graduate Research Fellowship Program. Congrats. His research interests are in transportation mode choice and demand modeling, especially as it pertains to the COVID-19 pandemic. After completing his graduate studies, Justin desires to enter the academic space to become a professor, continue conducting research, and be a mentor for other minority students pursuing research and careers in STEM. And he's gonna present about the COVID pandemic rollout and its impact on transportation demand. So Justin, go ahead. Thank you for presenting.
Thank you. Can you hear me all right?
Yeah.
Excellent. All right. So good afternoon, everyone.
If you can speak a little bit louder.
Oh, I'm sorry. Can you hear me all right now?
Yeah.
Okay, excellent. So yes, I will be presenting on whether the COVID-19 vaccine outroll had an impact on transportation demand, a case study in New York City. I also did this research along with my PhD supervisor, Dr. Md Sami Hasnine. So let me close this. An overview of our presentation today. First, we'll be talking about the research problem, followed by the question that came from this problem, our data collection process, our modeling approach, followed by the results and a conclusion. So the research problem, and as mentioned before, transportation models were not able to accurately forecast during the COVID-19 pandemic. There was an introduction of new factors besides the typical factors such as travel time, travel cost, travel distance, and socioeconomic factors, which go into typical mode choice and travel demand models. For instance, during the pandemic, even if public transportation was the cheapest mode of transportation offered or was completely free, there was obviously risk perception of the pandemic that was in place influencing people's decisions. So the typical factors, again, influencing people's decisions were affected by the pandemic, and the models that were the previous models were not taking into account these factors. So why is this problem important? Well, accurate forecasting could have helped mitigate the spread of the virus. So not only does the virus have an impact on transportation, but transportation also has an effect on the virus as well. Of course, if more people are traveling, we can expect that the virus is going to spread more. So of course, being able to accurately forecast during a pandemic would be important to help implement policies to mitigate the spread of the virus. And also research suggests that a pandemic with a scale similar to COVID-19 is likely to happen within the next 59 years. That's an estimation from a study from Duke, but as population is growing and as other things are going on, it's just estimated that we would see more global health crises. So it would be important, or it would be reasonable to use the information that we've gotten from COVID-19 to help improve our transportation models in the event that there's another pandemic. So our research question is, did first dose and complete dose vaccination numbers influence travel demand in New York City? So hopefully this works, the laser pointer, great. So on the right-hand side, we have a graph of travel demand and vaccination. So this is derived from Apple mobility reports. And at the end, I will hopefully talk about some limitations to that data. But essentially, when the pandemic came in early 2020, we saw that all modes of transportation drastically fell. They began to rebound as time went on. Excuse me. They began to rebound as time went on, but this led to reinfection or a second wave of the pandemic, and then transportation modes began to decrease. But in late 2020, we saw that vaccinations were released and vaccination numbers began to increase, and we see that transportation numbers also increase. So it would be pretty, easy to assume that just because vaccination numbers were increasing, this had a direct impact on travel demand. But it's possible that these two variables are correlated, or that there's another factor which is influencing both of them. So the nature of our study was to really examine not just if vaccination was influencing transportation, but also how much, and how much relative to other factors. So we collected data from a variety of sources. We not only looked at COVID-19 vaccination numbers, but we also looked at COVID-19 tests, positive tests, hospitalizations, deaths, as well as other data, searches on Google for COVID-19 related terms, COVID-19 policies, weather data, and trip purposes from Google community mobility reports. So we used these predictor variables as predictors for our dependent variable, which was driving, transit, and walking demand from, again, Apple Mobility Trends report. And we modeled all three of these modes separately, and we did them both pre-pandemic and post-pandemic. So there was a total of 12 models estimated in the study. So for the sake of time, we won't touch too much on our modeling approach, but we use ARIMA X modeling, and we, of course, estimated parameters for beta and standardized them so we can interpret them and compare the influence of the various predictor variables on one another. So briefly talk about our results. So this is what we have right here is our Manhattan pre-vaccine models. On the left-hand side, we have our predictor variables, and then on the right-hand side, we have driving, transit, and walking, our three modes of transportation in this study. And what we see is that in the pre-vaccine setting, we see that COVID-19 tests and COVID-19 positive tests had a negative influence on driving, transit, and walking as expected. We see that COVID-19 searches for COVID-19 on Google, as those were increasing, it was related with decreases in all modes of transportation. But our policy score, and essentially what the policy score is indicative of, is that a higher policy score would be indicating stronger policies or more policies being implemented. This was essentially derived from a study that was done at Oxford, which was rating policies in different countries. And we used their policy scores with policies implemented in New York City. And those policies were essentially presented online. So we see, though, that the policy score was the strongest sort of predictor or influencer for all three modes of transportation in this pre-vaccine model, even more than COVID-19 tests and positive tests. And just to briefly comment on this, an example that I was just thinking of earlier was, for instance, let's say there's an apartment across the street from me, and let's say everyone in that building was infected with COVID-19. Well, if I wasn't really aware of the fact that they're infected, it may not necessarily have so much of an influence on me. So as we continue to look at more of the results, we're going to see that more than just vaccination statistics and COVID-19 statistics, it was more so about what was like people's knowledge. So policies were made aware, searching for COVID-19, things like that, on which people were aware of were influencing people's decisions more than just the statistics themselves. So this is the Manhattan post-vaccine model. Again, we have our predictor variables on the left, and we have our various modes of transportation, driving, transit, and walking. We actually see that vaccination did not seem to have a very significant effect on driving and transit. We see that first dose vaccination did influence walking demand, but there was not a statistically significant effect on driving and transit. We see, though, that COVID-19 tests had a negative influence. And we see, again, the policy score variable kind of being the dominating factor, kind of influencing travel demand. We also see that searches for COVID-19 on Google were also having a pretty strong influence on travel demand. And then as we go to our Brooklyn pre-vaccine model, so I forgot to mention this, but we essentially modeled both Brooklyn and Manhattan, which are two boroughs in New York City. So New York City basically has smaller subcities, 5 smaller subcities called boroughs. So we sort of modeled both of those pre-vaccine and post-vaccine. So again, when we look at the post-vaccine scenario for Brooklyn, again, we see that COVID-19 searches and policy score were pretty much two of the strongest influencers. But what we will notice from the difference between Brooklyn and Manhattan, one of them being that in Manhattan, the estimations for the parameters for Manhattan for the policy score was significantly higher than that of Brooklyn. And we're going to discuss that if we have time at the end of this. So we see that in Brooklyn, vaccination did have more of an influence. So first, those vaccination rates did have an influence on driving, statistically significant. Again, they did have a positive influence, but they weren't statistically significant. So first dose vaccination had an influence on driving and transit, and then complete set vaccination influence on walking demand. And then again, but we still see sort of these kind of prevailing variables, searches for COVID-19 and the policy score as sort of the strongest influencers. So this again would seem to indicate that the implementation of stronger policies were discouraging travel, but also that the lifting of these policies, as the policies were being lifted, there was less of an influence of the policy, of course, on travel demand, which explains a lot of the increase in travel demand as we saw in the graph earlier. So again, vaccination and COVID-19 statistics were not as significant predictors as we expected. COVID-19 policies and searches for COVID-19 on Google seem to be strong influencers, and we see that in grocery shopping and a lot of the models was, as we see here, were statistically significant for all modes, which makes sense because people need to go grocery shopping. It's an essential form of travel. So we also found that vaccination had a stronger, was more statistically significant in more cases in Brooklyn than in Manhattan, but policy had a stronger influence altogether in Manhattan. And just some details about differences between Brooklyn and Manhattan. Brooklyn suffered effects of the COVID-19 pandemic significantly more than Manhattan. The case counts and the death rates were significantly higher in Brooklyn, even though the population is not as large. So you can expect that vaccination would be like more of a relief in Brooklyn than in Manhattan. On the other hand, Manhattan is twice as population dense as Brooklyn. Even though it has a smaller population, most of its population is condensed in a very small area. And there were a lot of strong policies implemented in Manhattan during this period. So I guess it would make sense that individuals in Manhattan were more so reacting to policy because it's a very tight environment. And if the government releases a policy, they're shut down, people are going to be a little bit more quicker probably to respond than as Brooklyn, which is a more suburban environment and less population dense. So these are some of the things that we believe sort of justify or explain the results that we found in our study. So that's all for this presentation. I want to know if there's any questions, comments, concerns, or anything. Thank you everyone for listening.
Thank you very much, Justin.
Thank you.
Anybody has question? Oh, Andressa has made a question in the chat. Excellent research, Justin. What is the temporality of your data? Quarterly? Have you thought about using another models besides ARIMA? Thanks.
Yes. So our data was like aggregated on a daily basis. If I go back to the predictor variable side, it was daily. Yeah. So all of these variables were daily. Like Google Community Mobility Reports provided daily data, Apple Mobility Daily. Everything was daily on here except for the searches. This was weekly, but we essentially used the same weekly value for all of the days in that particular week. Yeah. And then as far as using another model, we did do another study, where we did a similar approach with the ARIMA X modeling, except we compared it with like a Bayesian time series modeling, and we actually found that the results were actually very similar. We didn't do this in this particular study, but yeah, we have done another similar study to this using Bayesian along with ARIMA X. So.
Did you estimate any type of fixed effects in your ARIMA?
We did not.
Yeah. That should be I think you could look into that because you have all these, subgroups in your panel.
Yeah.
Or in your time series. I also wanted to ask about your results. So you see that there were significant result differences between Manhattan and Brooklyn in terms of modes. Like vaccine was influential in both, in increasing, not as much as the policy, like you mentioned. But in Manhattan, it was mostly walking, while Brooklyn, the influence was mostly driving and transit. Could that be explained just because of the, the normal use of these modes in those areas?
Yeah, that's a good point. That could possibly be an explanation. Another explanation, and I forgot to mention this, but one of the limitations of this research was the fact that Apple Mobility Reports data only provided information for people that were making requests for navigation on Apple Maps. And for instance, the driving demand, most people probably making requests for driving are likely like Uber drivers or ride-hailing services. So yeah, the data itself was, just being honest, may not have been the most reflective of the entire population, because it was only one Apple, data, and we understand that not everyone has Apple devices, and that may constitute, a particular, or a niche group, and especially those making requests for travel. So that's possibly.
When you try to publish this, don't you have to acknowledge the limitations, but it is random. It's a random sample. It's still a sample. Yeah. And I use Apple every day on my commute to work, even though I know the way, but I like to see like the time that it's going to take me, and I drive, I live in a city that everybody drives. So yeah, it has limitations, but I don't think it should prevent you from, I mean, it's very interesting and very clever use of available data to get some insights. I also, think that there's a lot of other implications that you didn't discuss. I'm sorry I didn't take notes, but it's really, really cool. Anybody else want to ask some questions to Justin? We have 4 minutes until the pet parade, so we can squeeze another question. Okay. Well, thank you so much, Justin.
Thank you.
And thank you all our presenters. This was a great session to have on a Friday afternoon. I enjoyed all the presentations. And just like Kara said, we'll be going to a pet parade soon. Don't miss it. You'll see my dog and a lot of others. I'm looking forward to it. Thank you for attending. Thank you for presenting, and see you at the next session. Have a good weekend.